Hello student, today I'm going to discuss some problems on friction. So here the question is a body of weight W just be sustained on a rough inclined plane by a force P and just drag up the plane by a force Q. What does it mean here? It means a body which is acting on a rough, which is lying on a rough inclined plane. So this is a rough inclined plane, okay, of inclination alpha to the horizon. It is just sustained on by a rough it is just sustained by a force P, which is acting, as you can see, P and Q, they are acting up at the line of the greatest slope, means they are acting along the line, the inclination, inclination of their slope. So here we have it, case 1, it is just sustained by a force P. So in this case, the position of this body, which is lying on an inclined plane, is in the point of moving downwards. So if it is on the point of moving downward, as we know, R is the normal reaction, mu R, the force of friction which acts opposite to the direction in which the body has a tendency to move, will move outwards, right? Because the body in this case 1, when it is acting by a force P acting along the inclined plane, it is in the position of moving downwards. So if W is the weight of the body, as you can see in the figure, so the result part of this force W along the inclined plane and perpendicular to the plane, they are W sine alpha and W cos alpha. So based on this figure, for figure 1, case 1, we can resolve the forces along and perpendicular to the plane. So case 2 here, it is and just drag up the body and just drag up the plane by a force Q. So this force Q here is pulling the body upward. So in that case, the body has a tendency to move down or upward. So the force of friction which opposes the motion of the body, that is mu S. If S is the normal reaction, it will act downward. So again, the same thing, only W here will be the resultant, as we can see here. So W here is the weight. Okay, W is the weight of the body. So resolving the forces along and perpendicular to the plane, it will be W cos sine alpha and W cos alpha. So along this inclined plane which acts downwards, what are the forces? W sine alpha and mu S, they are acting in the same direction, whereas Q is acting upward and which pulls the body upward. So in that case, the force of friction mu S will act downward. So let us discuss the result here, how to show that the coefficient of friction, that is mu, is equal to Q minus P by square root of 4W square minus P plus Q the whole square. So what we have to do here is solution. Let alpha be the inclination of the plane to the horizontal. So as you can see here, the alpha here is the inclination of this plane to the horizontal. Now what we have to do is that, based on figure 1, case 1, okay, case 1, when a force P, which is just supported this body, okay, is acting along the inclined plane, along the direction of the inclined plane, supports this body from moving down. So in this case, the body has a tendency to move upwards. So if it has a tendency to move downwards, the body has tendency to move downwards. The force of friction mu R will act upwards. So here, as in figure 1, case 1, the body has a tendency to move downwards. So the force of friction mu R act R here, R is the normal reaction perpendicular to the inclined plane. So the inclination of the plane here, as you can see in this figure, it is alpha. Now from figure 1, as you can see from figure 1, resolving the forces along and perpendicular to the plane. So resolving the forces along and perpendicular to the plane we have. So based on this figure 1, what are the forces along the plane? The forces along the plane, they are W sine alpha, P and mu r. But P and mu r, they are acting in the same direction. So the horizontal along the plane, it is P plus mu r is equal to W sine alpha. Name it as equation 1. And what about perpendicular to the plane? It is R and W cos alpha, but they are in opposite directions. So we have R is equal to W cos alpha, equation 2. Now, so using 2 in 1, using equation 2 in 1, we get P here, okay, P plus mu into W cos alpha is equal to W sine alpha. So which implies that P here will be equal to W, I can take outside, so sine alpha minus mu cos alpha. And what is mu here? Where mu here is equal to tan lambda, and lambda is the angle of friction. So you, based on figure 2 now, case 2 is based on figure 2, case 2, from figure 2, in case 2, a force Q is applied which will drag the body up the plane. So in this case, the body has a tendency to move down upwards. So if it has tendency to move upwards, then mu s, the force of friction, will act downward, where s here is the normal reaction. So based on figure 2, what we have is that the body, let S be the normal reaction perpendicular to the plane. The plane here is an inclined plane of inclination alpha. Then inclination alpha. So the body has a force. So in this case, the body is moving upward by applying a force Q, which is acting along the inclined plane. So based on this, so therefore mu s, the force of friction, therefore mu s will act downward. Okay, so resolving again the same thing only, resolving the forces, along and perpendicular to the plane. What are the forces along the plane? They are W sine alpha, mu s, and the cube. But W sine alpha and mu s, they are in the same direction. So we have here Q is equal to W sine alpha plus mu s. Name it as equation, because this last equation, what is that equation number I named? I should have named this one as equation 3. So now let me name this next equation. This one as equation 4. And what about based on this, based on the given figure, what will be S? S will be equal to force perpendicular to the plane. It is W cos alpha, equation 5. Now using 5 in 4, we get, what do we get? Using 5 in 4, we get this one. Cube is equal to W sine alpha plus mu, but S you replace it by W cos alpha. So once you replace it by W cos alpha, you can take W common here. So W into sine alpha plus mu cos alpha, name it as equation 6. Now what we do next is, what is equation 3? Equation 3 is P is equal to W sine alpha minus mu cos alpha. So subtracting so I can write here subtracting 6 from 3, we get, so the left hand side of this, subtract with the left hand side of 3, so you have cube minus p. Cube minus p will be equal to, what is cubed here? It is W sine alpha. I can take common W for all the terms, plus mu cos alpha, and then minus W minus sine alpha, minus into minus will become plus, so mu cos alpha. So next step, as you can see, what are the term that can be cancelled from here? As you can see from the figure, sine alpha and minus sine alpha can be cancelled out. So this will be equal to this, and this can be cancelled. So what remain here is W into mu cos alpha plus mu cos alpha, and which is nothing but twice W mu cos alpha. So you have the value of Q is equal to the Q minus P is equal to this, and from here it implies that Q mu here, take the value of mu from this, the left hand side is Q minus P, so you have here mu is equal to Q minus P divided by twice W cos alpha. Name this as equation 7. This as equation 7. Now next you do is you add equation 6 and 7, 6 and 3. So this is equation 3 and this is equation 6. So what you have to do is you add them. So it will be P plus Q, adding at 3 and 6. We have Q plus P will be equal to, as you can see here, what is cube? Cube is W sine alpha plus mu cos alpha, and then plus sine alpha minus mu cos alpha by adding 3 and 6. So mu and this mu will get cancelled. So this will give you twice w sine alpha. So this implies that w p plus q is equal to, so which implies that q plus p here is equal to twice w sine alpha. And from here we can find out the value of sine alpha, which implies that sine alpha is equal to q plus p divided by twice w. And we know that what is cos alpha? Relation between sine and cos, it is square root of 1 minus cos square alpha. So this implies that sine square alpha. So cos alpha will be equal to square root of 1 minus sine square alpha. And what is this value? It is equal to 1 minus, what is sine square? It is q plus p the whole square divided by 4w square. So which implies that cos alpha here is equal to square root of, bring this LCM here, it will be 4w square minus q plus p the whole square divided by 4w square. So which is same as 1 by twice w into square root of 4w square minus q plus p the whole square and the square root. Okay. So name this as equation 8. Now using this equation 8 in 7, we have to find the value of mu, the coefficient of friction. So using 8 in 7, we have mu, which is equal to q minus p divided by this one twice w, okay, 1 by w here, divided by what? So 1 by twice w, this is 1 by twice w because cos alpha. So you place cos alpha by this value we obtain in equation 8. So you have 4w square minus q plus p the whole square. So the twice w cancel. So this implies that mu here will be equal to q minus p divided by square root of 4w square minus q plus p the whole square. So this gives you the coefficient of friction of the given problem. Next we come to the next question. I hope it is clear with this one. By resolving the forces based on figure 1, figure 2. So we have to find out the value of the coefficient of friction. So next is a body here is, question is a body is supported on a rough inclined plane by a force acting along the plane. It is supported by a force acting along the plane. Now suppose the greatest magnitude of the force to be double the least magnitude. Find the inclination of the plane. So we have to find the inclination alpha here. So what we have to do is, the body is in the position of moving downward and it is supported by a force. So it's supported on a rough incline by a force. So let that force which support this body from moving downwards be P. So solution, a body is supported on a rough inclined plane by a force P. So the body is, let the body be supported by a force P along the inclination alpha, along the inclination of the plane. So here this is the force P here which support the body. So in this case the body has a tendency to move downward. So or we can say here in this case the body is moving downwards. So if it is moving downwards, so mu r, the force of friction, is moving upward. So resolve where r here, what is r? Where r is the normal reaction. So R here is the normal reaction. Now let us resolve the forces. Resolving the forces along means along the inclined plane and perpendicular to the plane. So along and perpendicular to the plane. And the plane here, it is an inclined plane. This is an inclined plane of inclination alpha to the horizon. So by resolving the forces along the plane, as you can see from the figure, what are the forces along the inclined plane? They are W sine alpha, mu r and p. But mu r and p, they are in the same direction. So we have here p plus mu r is equal to W sine alpha. Equation 1. And what is r here? It is W cos alpha, equation 2. So using 2 in 1, we have P is equal to, bring mu r to the left right hand side, you have W sine alpha minus mu into, instead of r you replace it by W cos alpha from equation 2. So we can take W into sine alpha, similar to the preceding problem. So we have mu cos alpha. And what is mu here? Mu here is tan lambda. So therefore we have this implies that P here is equal to W into sine alpha minus tan lambda into cos alpha, where mu here is equal to tan lambda. So which can be written as W into sine alpha minus tan lambda, instead of tan I'll write it as sine lambda by cos lambda into cos alpha. So by taking the LCM here, you will have W into sine alpha cos lambda minus sine lambda cos alpha divided by cos lambda. Or you can write here, P here will be equal to W. The denominator will be, numerator will be of the form sine A minus B. That is sine A minus B gives you sine A sine cos B minus sine B cos A. So here treat this A as alpha and lambda as B. So you have sine of alpha minus lambda divided by cos lambda. So this is same as W sine of alpha minus lambda, but we know that 1 upon cos lambda is secant lambda. Since you can mention here, since 1 upon cos lambda is equal to secant lambda. So you name this as equation 3. So this gives you the least value of the force P. Now when the body is in the position, but now according to the question here, when the force P is double, the body is the position of moving upward. So let us go back and see the question. Suppose here the greatest magnitude of the force to be double, that is the greatest magnitude of this force P is double, means twice of P, then the body will move up the inclined plane. So in that case, the force of friction will act downward. So let us see here what will be the case. Now I should have drawn the figure here. When the body is in the position, when the body is moving upward, by applying a force Q, which is equal to twice of the force P double. Okay, so here you have this inclination, the same inclination. This is alpha and the body is here. So by applying a force Q here is equal to twice P. So the body is in the position of moving down upward. So here the force of friction mu S, I can see here, or mu R. Okay, mu R, the same thing only. Mu R, R here is the normal reaction, and W is the weight here. So the result part of this will be W cos alpha, and this will be W sin alpha. So when the body is in the position of moving upward, so by applying a force Q is equal to twice P, mu R, the force of friction, is moving downward, where R is the normal reaction. I will not mention again here. So here what I have to do is that resolving again the forces. So resolving the forces along and perpendicular to the plane. The plane here means an inclined plane. Okay, inclined plane. What do we have here is, what are the forces along the inclined plane? Along the inclined plane, they are mu R, W sin alpha, and Q. So we have twice P. We have Q here is equal to mu R plus W sin alpha. And what is this normal reaction? Perpendicular to the plane, R is equal to W cos alpha. Name it as equation 4 and this as equation 5 using 5 in 4. We get Q here is equal to W cos alpha, mu W cos alpha plus W sin. You just replace R by W cos alpha. So this implies that Q here, the same thing only, tan lambda into cos alpha plus sin alpha by taking W outside. So replace this sin lambda, cos lambda. So this will give you, this is sin lambda by cos lambda into cos alpha plus sin alpha into W, which is nothing but sin lambda cos alpha plus sin alpha cos lambda divided by cos lambda into W, being a common term for all this. So sin A, this is sin of alpha plus lambda divided by cos lambda, which is same as W sin alpha plus lambda into secant lambda. So this implies that Q here will be equal to W sin of alpha plus lambda into secant lambda. So, but what is Q here? According to the question, it is double of the force P, because the force P is just sufficient to sustain the body on the inclined plane, whereas force Q here is, which is of maximum magnitude, force of maximum magnitude, that which is double of that force P, that is twice P. Q here is called twice P, is applied such that it drags the body up the inclined plane. So in this case, but we can see here, but name it as equation 6, but Q is equal to twice of P. And what is this Q here? Q is equal to twice P. So therefore what we have is this implies that twice P, 6 implies now, is equal to W sin of alpha plus lambda into secant lambda. Now name it as equation 7. And what is the equation 3? Equation 3 is P is equal to W sin alpha minus lambda by into secant lambda. So dividing the 7 by equation 7 by 3, we get, what is equation 7? Equation 7 is twice p equal to w sine of alpha plus lambda into secant lambda. And what is equation 3? From the left hand side it is p, and from the right hand side it is w sine of alpha minus lambda into secant lambda. So the common term can be cancelled, w, and here also pp. So this implies that 2 here is equal to sine of alpha plus lambda divided by sine of alpha minus lambda. Now cross multiply this and expand it. So this implies that twice of sine alpha minus lambda is equal to sine alpha plus lambda. So, or you can write here 2 into sine alpha minus sine alpha cos lambda minus sine alpha lambda cos alpha is equal to sine of alpha cos lambda plus sine lambda cos alpha. Or you can write here twice sine alpha cos lambda minus twice sine lambda cos alpha is equal to sine alpha cos lambda plus sine lambda cos alpha. So, or you can write here, bring this sine alpha cos lambda to this side. So you'll have twice sine alpha cos lambda. Bring this to this left hand side, you'll have minus sine alpha cos lambda. And whereas you bring this to this side, because of negative sign, when you take it to the right hand side, it becomes plus. So sine lambda cos alpha plus twice sine lambda cos alpha. And from here, what remains, you will get sine alpha cos lambda is equal to 3 sine lambda cos alpha. Now, or you can write here, divide throughout by cos lambda. So sine alpha is equal to 3 sine lambda by cos lambda into cos alpha, dividing both sides by cos lambda. So this will be equal to 3 tan lambda into cos alpha by from left hand side is sine alpha. Now again you divide both sides by cos alpha. What do we get from the right hand side will get cancelled, whereas from here you will get the right hand side, left hand side will be sine alpha by cos alpha gives you tan alpha is equal to 3 tan lambda. So this implies that alpha is equal to tan inverse of 3 tan lambda. But what is tan lambda? Tan lambda is equal to mu. It is equal to the coefficient of friction. So this implies that alpha is equal to tan inverse of 3 mu. So this is an important question. It used to come. Okay, both the two questions that I have explained here, they are very important. They used to come during an annual or a semester exam. So I hope it is clear now how to find the inclination of the plane, that is alpha, which is called tan inverse of 3 mu. When you apply the force in the beginning, you apply the force P, which is just sufficient to sustain the body along the inclined plane. And the second is that when the force of the magnitude is maximum, means you apply the maximum force, which is 2 times of that force P, then the body starts moving upward. And what is you have to find is find the inclination of alpha. So by resolving the forces along and the incline along and perpendicular to the inclined plane, what we have seen here, we have got the value alpha that is equal to tan inverse of 3 mu, where mu here is equal to tan lambda.